Okay, box and whisker plot. So once again, all of you don't have this technology, or the idea is most of the stuff is going in the calculator. So once again, this is another old school lesson, but let's just talk about what. First of all, we get to this. What have we been doing? Well, the first thing is you went out and collected. You decided talked about data. Then the next thing we did was we went out and collected data. Maybe it was discrete, maybe it was continuous. The next thing we did was we organized the data and we put it in tables. We counted it up, put it in tables, and we decided, so with discrete, maybe we had a small enough sample or there was enough of each that we can make a nice small table of, like four, 1, 2, 3, 4. And we maybe had a frequency of like 10, 11, 5, 1. So for example, we found discrete data and we said, oh, you know what? Here's the value, here's the tally, which we called frequency. Maybe it was like 1, 2, 3, 4. I think the example was how many times people took the bus. And we were like, okay, it's 8, 11, 3, 15. Number of times a week people took the bus. This was our frequency. This was discrete. We also encountered continuous data. And with that, we used the intervals. Continuous data. And we split that up into the intervals. So for example, we talk like kids from 0 up to 10. Or, 10 up to, but less than 20. 20 but less than 30, and the same idea. We made a tally, a frequency table, and that was it. That was 15 to 9. So the idea was you're a statistician, you go out and collect data. In this class, we talked about numerical data. We organized it, and then in the last couple of classes, what was in the last class? Yes. In the last class, we said, how do we represent this data? What's the best way to represent the data? In the last class, we said, oh, you know what? We can use mean, median, and mode. And I think you've studied this over the years. And so in the last class, we said the mean was the sum of the data over the number of data points. We called the median the organized middle. And then we also introduced a concept called the mode, which I'll change it a little bit, but the idea was it occurred the most. Now, as I said before, you can do all this stuff in your graphing calculator. So it's a little, my lesson's a little old school. Once again, because everyone doesn't have a calculator, I'm a little torn. So, let me still teach the old school lesson. What's another way to represent the data? So, I'm sorry, let me close the shades because I can see the glare on the window. Let's see if that's a little bit better. Okay, so what's another way to represent the data? Well, today let's talk about other ways. Today we're going to talk about, first, we're going to define the range. Sorry. First, new word, range. The range is the max minus the min. So, yes. The range is the max minus the min. That's one way. So, for example, we know that in this example, the minimum was 1, and the maximum was 4. So the range is 4 minus 1, which is 3. So we kind of have this idea of a spread and that's what we're moving towards, how the data is spread out. Okay, the next thing we want to do is this idea of quartiles. Quartiles, and the idea is we're going to split the data into 4 parts. So we will separate the data into 4 sections. And We're going to set in 4 sections. Sorry. Sorry. Okay. So what we're going to, so let's just jump right into an example. So here's your data. And I'm going to make this work out nicely. As I said before, all this data goes in the graphing calculator, and it's just quick, but let's go old school today. The data points are 1, 2, 4, 6, 8, 9, 11, 11, 12, 13, 14. This is the data you collected. And once again, we can easily find the mean, we can easily find the median, we can easily find the mode, we can find the range. We can use the technology. Hey Siri, 1 plus 2 plus 4 plus 6 plus 8 plus 9 plus 11 plus 11 plus 12 plus 13 plus 14.
1 plus 2 plus 4 plus 6 plus 8 plus 9 plus 11 plus 11 plus 12 plus 13 plus 14 is 91.
Let's see, 1, 2, and this is 11, n equals 11. Hey Siri, 91 divided by 11.
91 divided by 11 is about 8.2727.
Okay, so, and then the mode, so that's the average, and the mode is 11, and what's the median? And the median is, let's see, well, we have 11 pieces of data, right? 11 plus 1 divided by 2 is 6. 1, 2, 3, 4, 5, 6. This is the median. The median is 9. Okay, what else can we do with this data? Well, now we can find the range. The range is 14 minus 1, which is 13. Well, today's lesson is box and whisker plot. Let's start. First thing, find the median. Let's see. First, find the median. Well, the median we know is 9, right? You see that? So what I'm going to do is take my red pen, and I'm going to draw the median right here. I'm going to erase this. Let's see, 8.27. So first we found the median. Okay. Next, what we're going to do is we're going to split the data into a lower range and an upper range. So this part is the lower range, and this part is the upper range. So this is the median. This is our lower range, and this is our upper range. Next, I want you to find the medians of the upper and the lower range. So I made it easy. We have 5 pieces of data. So lower, smallest, biggest. Smallest, biggest, here's the middle. And then let's find the median of the upper range. 11, 14, 11, 13, 12. Okay. So what we've done is we've broken up our data into 4 parts. These separators are known as the quartiles. So this middle, this is known as the lower, sorry. This is known as the lower quartile. We're going to call it Q1, and it's the lower quartile because 25% of the data is below, and 75% of the data is above. You can visually see that. 25% of the data is below 4, and 75% of the data is above 4. What's going on here? We're just going to call this Q2. This is the median of all the data. And it's the median because 50% of the data is below, and 50% of the data is above. Last, we have our third quartiles. This is known as our upper quartile. We're going to call this Q3. And once again, 75% of the data is below, and 25% of the data is above. Now, next year, you're going to be asked to find a specific quartile, like the 60th quartile or the 15th quartile, and that's a specific piece of data here. So this is all out of 100%, but the important quartiles are the 25th, the 50th, and the 75th. Now, here's where the box and whisker. So what I did was, you can see I put my data out, I drew in the medians. What we're going to do is, we're going to draw a box. That. Then what we're going to do is, you're going to put a circle over the min, you're going to put a circle over the max, and then draw whiskers. And what you've done is you've drawn a box and whisker plot. This is a box and whisker plot. And once again, so let me simplify that down here. It doesn't need to be perfect like this. It could look like this, This is another example of a box and whisker plot. Once again, this is the min. This is quartile 1. This is quartile 2. This is quartile 3. And this is the max. Now, what's great about the median, it's just literally the middle, the score that's in the middle. So it could be all the numbers are the same, and then there's one number off, so all these things are the same number. It's not like they affect each other. What else do I want to say? That's the box and whisker plot. The last thing is something called the interquartile range. The interquartile range, and that is simply the Q3 minus the Q1. And so in this unit, we're interested in just the spread of the data. The exercises in the book, 7F and 7G1, you can work on that. As I said before, most of this is going into the GEC. You actually can make a box and whisker plot in a calculator that's acceptable for IB. So until everyone gets calculator, I'm still going to teach an old school lesson. But if you want to, I'm trying to get the license. So I'm going to put a little video of how you can do all this in your graphing calculator. Good luck.